Question 32. The posted weight limit for a covered wooden bridge in Pennsylvania is 6,000 pounds. A delivery truck that is carrying X identical boxes, each weighing 14 pounds, will pass over the bridge. If the combined weight of the empty delivery truck and its driver is 4,500 pounds, what is the maximum possible value of X that will keep the combined weight of the truck, the driver, and the boxes below the bridge's posted weight limit? This question, like most SAT questions, requires that you comprehend it and most times mentally visualize it so as to know how to approach it. Going back to the first sentence, we have the posted weight limit for a covered wooden bridge in Pennsylvania is 6,000 pounds. So what this is saying is that the bridge can carry a total load of 6,000 pounds. Any load greater than that can cause the bridge to collapse or break. The next line says a delivery truck that is carrying X identical boxes, each weighing 14 pounds, will pass over the bridge. The second sentence is talking about a truck carrying identical or same boxes, each weighing 14 pounds. That means we don't have the exact amount of boxes, or the exact amount of boxes in this case, or the number of boxes in this case is represented with X. X can be 20, can be 50, can be 100 boxes, but they all weigh the same. The third sentence, if the combined weight of the empty delivery truck and its driver is 4,500 pounds. That's what this line is saying before the comma, is that the weight of the truck itself and the driver in it without the boxes totals 4,500 pounds. And note the first sentence says the wooden bridge can carry a total of 6,000 pounds. That means if you take the weight of the truck and the driver, which is 4,500, and subtract it from the maximum amount of weight the wooden bridge can carry, which is 6,000, you'll be having 1,500 left. That's 6,000 minus 4,500 will give you 1,500. That means the maximum weight of the boxes should be 1,500 for it to go over the bridge. This visual could help a bit, although this is not an actual big truck. This is just for illustration. Let's say this is the truck and this is the driver. They both weigh 4,500. The maximum weight that can go through this bridge without causing it to collapse is 6,000 pounds. That means if both the driver and the truck weigh a total of 4,500, the identical boxes should all weigh 1,500 for the total weight not to be above the 6,000 pounds weight limit to go across the bridge. Back to the question, we have the delivery truck carrying identical boxes, each weighing 14 pounds, will pass over the bridge. We've been given the number of boxes as X. Number of boxes is X. Each box weighs 14 pounds. So if each box weighs 14 pounds, to get the total weight of the boxes, let's say for example you have two boxes. The total weight of the boxes will be 14 plus 14 if you were to have two boxes, or you do 14 times 2. If there were 5 of them, it's either you add 14 in 5 places or you do 14 times 5. And in this case, since the number of boxes is X, total weight of boxes will be 14 times X, which is 14X. And you know, as calculated earlier, the total weight of the boxes should not exceed 1,500 pounds, which with the weight of the driver and the truck would add up to the exact weight limit, which is 6,000 pounds. So if the weight of the truck and the driver is 4,500, I'll take 4,500 from the weight limit of the bridge, which is 6,000. The rest will be 1,500. That means the total weight of the boxes should be maximum 1,500. And since we have the total weight of the boxes as 14x, we can see 14x equals 1,500. The x stands for the total number of boxes. The 14 represents the weight of each box. And we've been asked to find the number of boxes, or in other words, the maximum possible value for x. That's the maximum possible value of the number of boxes that will be within this weight limit. So we divide both sides by 14. 14 cancels 14. X equals 1,500 divided by 14 will give you 107.1428 and so on. We can't have a number of boxes with decimals, so we approximate to the nearest whole number. So x equals 107. If this were 5, it's best you leave it at 107, because if this were 5 and you were to approximate to 108, in this case, the weight of 108 boxes would be higher than the 1,500 pounds weight the total boxes are meant to weigh, which should be the maximum weight of the boxes. But this is a very good case where you have a digit less than 5. Therefore, when we approximate, we have 107. Therefore, the maximum possible number of boxes that would not exceed 1,500 pounds is 107 boxes. X is 107 boxes. Hope you understand. Why 107 boxes is the perfect answer is, if you multiply 107 by 14, you get 1,498. That's 1,498 pounds. Let's assume this were to be 5 and you had approximated it to the nearest whole number and you had gotten 108. It's best to do a test by multiplying the 108 by the 14 and see if you get a value less than 1,500 or more. If you multiply 108 by 14, we'll get 1,512, which is actually higher than what is meant to be left for the total weight of the boxes. So you should be careful with your approximation. In a question like this, check by multiplying the result by the weight of a box, in this case, which is 14. So you should be sure your answer is correct. Apart from this way of solving this question, there's a similar way to solving this question which is more standard. Let's have a picture like we did with the first method. Normally, you should have this mentally. That means you need the mental picture to comprehend the question. We have the weight limit of the bridge at 6,000 pounds. That means the total weight that should cross the bridge per time is 6,000 pounds. That means we are taking this truck as the only truck crossing this bridge at this point in time. And as said in the question, that the weight of the truck and the driver sums up to 4,500 pounds. If you are to put this mathematically, we will have the weight of the truck, the driver, and the boxes equal to 6,000 pounds. We have the weight of the truck and the driver together. So weight of truck and driver plus the weight of the boxes should equal 6,000 pounds. We can therefore say 4,500 pounds, which is the weight of the truck and the driver only without the boxes, plus the weight of the boxes, which in this case is 14x. That you calculate that by taking the weight of a box times the number of boxes. Here we're given the number of boxes as x. That it could be 20, it could be 30, it could be 100, and so on. And the weight of a box is 14 pounds. That means if you want to get the weight of the total boxes, it will be 14 times x. If there were 2 boxes, it's either you do 14 plus 14, that you add 14 in 2 places, or you do 14 times 2. And since in this case we have a total number of boxes as x, it's best we do 14 times x. So we have the total weight of the boxes as 14x should now equal to the weight limit of the bridge. That's the total weight that can go through the bridge per time. So we have it equal to 6,000. So we have the weight of the truck and the driver plus the weight of the boxes should equal 6,000 pounds. That's the maximum weight we can have go on the bridge without causing it to collapse. We're looking for x, so we'll take this 4,500 to the right. We have 14x equals 6,000. Then this is positive 4,500, crosses the equals to sign and turns to minus 4,500. 14x equals 6,000 minus 4,500 would give you 1,500. We divide both sides by 14 to have x alone on the left. Divided by 14, divided by 14. 14 cancels 14. X equals 1,500 divided by 14 will give you 107.1428 and so on. You have other digits behind the decimal. It's a continuous one. I said using the first method, even if you have a 5 here, do not approximate it the normal way you approximate. Because if you calculate the weight of the boxes using the number of boxes, I add it to the weight of the truck and the driver, you get above 6,000. So you have to be careful here. It's not just normal approximation, this is technical. So you have your x equals, so you approximate to the nearest whole number, you have 107. So we have our answer as 107 boxes. This is more standard in solving this question.